Hey guys, welcome to this week's advanced concept presentation. So today we're going to be demonstrating some chemistry, working with some pennies, some salt, and some water and some vinegar. So the experiment is quite simple. First, we're going to grab some dirty pennies. As you can see, um, I have some dull, dirty ones in the mix, and then I'm going to pour some vinegar, some white vinegar into a bowl container, and then simply we're just gonna add some salt. And once we have that, we're just gonna put the pennies and into that mixture and observe what happens. All right, so after letting them sit in a while and mixing it and drying the pennies off, we can see that some big change uh, from these. As you can see, they look much more clean as compared to, let's say, like the duller ones that I had before. You can see the difference. So earlier this week we talked about ions, hydrostatic charges, such as with the transfer of electrons from our hair to the balloon in the hair balloon experiment, or even the lava lamp experiment. We saw the interactions of ions play a role in between polar and non-polar molecules in the visual demonstration of bubbles forming as a lava lamp simulation, and ions play a role here as well. And here we understand that pennies, they get a dull color when the copper in the pennies react with oxygen to form copper dioxide. In this experiment, we can see from our observations that the visible change from dirty to clean pennies, the combination of acetic acid in vinegar and sodium chloride from the table salt, it shows that it reacts with the copper oxide, and it ultimately dissolves it. And our results, as we can see, that through this visual cleaning or the unrusting of the pennies. And in chemistry, we understand that there's typically two types of changes: physical change and a chemical change. This type of unrusting involves chemical change, as the matter changes chemically into an entire different substance, with the interaction of acetic acid and vinegar and table salt, dissolving the copper oxide to form the blue copper ion, which is soluble in water. And essentially, the copper atoms, they leave the penny and they start floating around in the liquid. And from that, we're able to see our pennies being cleaned. Yeah, thanks for watching and tuning in for this week's experiment. It was short and simple, but from this, I was able to achieve some successful results, as we can see from the visual, visible change in the cleanliness of the pennies. And like always with science, any experiment should be reproducible, and on trials, additional trials is important to uh, maintaining more accurate and consistent results.